My name is Manuel Casasola Merkle. Hello. I'm a technical director and co-founder of Aixsponza in Munich. That's a small design and 3D studio. We do mainly commercials, trade shows, game trailers, basically everything but feature film, because doing feature film in Germany is not that easy, especially for a small shop as ours. And we are known to be a Cinema 4D shop, so we have our 10th anniversary next year, and we are using Cinema 4D from the start up. And some time ago, a very nice addition to the Cinema 4D toolset hit the ceiling, and this is Arnold, the well-known post tracer by Solid Angle. And this renderer is around for quite some time, but was available only to big studios and for other applications like soft image. And nevertheless, people heard about it, that big Hollywood movies like Elysium or Gravity have been rendered with Arnold. But it was always out of scope because only volume licensing was available. But now Solid Angle opened up this ecosystem and brought Arnold to Cinema 4D. Not at last because of the effort of a guy called Daniel Hennies, who is a German 3D artist who desperately wanted to have Arnold inside of Cinema 4D and did quite a lot to make this happen. And today I want to walk you through the Arnold implementation in Cinema 4D that is quite nice. But before I do so, let me quickly show you our showreel, just so that you know what we are doing and who we are. That was that. Thank you very much. Let me play the Arnold showreel in the background while I describe a little bit what this render engine is all about. Arnold is a path tracing rendering engine. That means it calculates all the rendering effects through ray tracing. And this is a big advantage because it's very, very easy to set up. And it's very memory efficient and it's very fast. You don't have to bother with acceleration structures as with other engines, calculating irradiance maps or baking irradiance or something, but you can have all the rendering effects delivered immediately by just throwing it at Arnold, and Arnold ray traces it. And that means everything you have to set up is the ray tracing kernel. You have to deal with rays, you have to specify how many rays Arnold shoots, and that's the quality of the engine, and it gives back to you beautiful images, as you can see here in the show reel. And this is the one big strength of Arnold, that it's very easy to set up, because nowadays artist time is very expensive, computer time gets cheaper and cheaper, so it's probably a good idea, especially for studios, to let the computers do the work instead of the artists. And the second thing that's really exciting about Arnold is the implementation inside of Cinema 4D. Solid Angle did a really fantastic job integrating the engine into cinema, because it feels really deeply integrated, it feels native, and it offers a lot of stuff that we did not have before inside of Cinema 4D. Let me switch to the application and show you what you can do inside of Cinema 4D with Arnold. So basically, the first thing I want to talk about is where can you find Arnold inside of Cinema 4D. And if I switch to Cinema, you see the interface you all know and love, and not very astonishing. You will find, if you installed everything correctly, and that's a very easy process, even the licensing is very straightforward. No need for licensing service and stuff. If you have a node-lock license, just put it in there and it works. And you find the Arnold renderer in the renderer menu, where all your third-party renderers are. And once you do so, you have here this Arnold menu and all the Arnold subtabs, and these give you the options to set up the renderer. And where you find, normally you find a huge bunch of tabs here. With Arnold, it's a little bit different. It's only 5 tabs, and these are not that important. The important stuff is really the sampling controls here and the ray depth. And that's it. If you understand what these sliders do, you understand Arnold, and you can go rendering straight away. It's really like that. Then we have a thing that's really exciting, I think. We have this Arnold menu here under plugins. I quickly create a menu from it and create an Arnold Light. Solid Angle implemented a new window into Cinema 4D called the IPR, the Interactive Preview Renderer. And if I click on this, I get this rendering window. And the beauty of this window is, once I press play here, I can navigate my viewport and see the changes updating instantly inside of Arnold. And this really makes a huge difference. When I create a plane, for example, I see the plane immediately in my rendered image, and this is no preview core or something. This is Arnold delivering images with undersampling that's very fast, interactive, and you see what you do instantly. And this makes all the difference, because quality in 3D images is achieved by iterating. You have to iterate and iterate again, and the standard workflow is to create something, then take a test render, look at the test render, change stuff, take a test render again. And this is really very tedious. And with this interactive render window, you don't have to do this anymore, because you see the global changes happen in real time. So if I, for example, up the exposure of the light, I exactly see how light my scene is, and how to set the slider. So setting up lighting, setting up reflection, setting up shaders is very straightforward. And it really makes a difference, because you do more iterations, and that means you get better images, just because of this window here. Then, of course, we have Arnold Tag, because tags are the Cinema 4D way of specifying options. So under C4D2A, you have this Arnold parameter tag. If I apply this tag to an object, I get all the Arnold-specific settings, like, for example, the visibility controls or subdivision for displacement and stuff like that. And this tag is very smart, because it takes into account on which object you apply the tag. If you put it on a geometry object, you get the geometry controls. If you put it on the camera, you get camera controls. There is no need for selecting the right tag, but the tag automatically understands which object type this is and gives you the right settings. And then there is a lot of other convenient stuff, but more on this later. And then the best, greatest, most fantastic addition to the Cinema 4D tool set ever is the Arnold material. Because if I create an Arnold material, I get a shader ball, as with all the other renderers in Cinema 4D. But the difference is that I get this button here. And if I click this, Nodal shader network opens. And I cannot tell you how excited I was when I saw this for the very first time. Because this is something I was begging for years now. We had this 10 years ago with Final Render, but Final Render did not have a very bright future and is not around anymore. I think you can buy it, but nobody does. And now the shading network is back again, done by Solid Angle. This is very straightforward. Fortunately, they decided not to do their own thing, but adopt the Cinema 4D specific nodal interface. So the nodes look a lot like Espresso nodes, and it works the same. So on the left, you have this library of nodes. For example, I can go to Surface and create a standard shader, and you get a node that awfully looks like an Espresso node. But don't get confused. These are not Espresso nodes. You cannot use Espresso nodes in this interface because this is all pre-compiled stuff because it has to run very efficiently and fast. So it's not possible to do something like Espresso where everything is interpreted. But it works the same. You can type here, if you search something, a utility node for, I don't know, math or something, the panel on the left updates immediately and you can drag your nodes and you connect them exactly in the same way as you would with Espresso network. And on the right here you have the parameter panel, and if I select the node, I immediately see all the parameters of the node on the right and can change them there. And I have a shader ball that updates. If I have two materials, let's say another one, this manager is smart and updates the material you click. So no need for pressing the button every single time, but just keep this open, even dock it to the layout. There's no problem with docking it here, and then you can edit all your materials directly. And this is really more or less everything there is to Arnold. I prepared some scenes for you to explain Arnold to you a little bit. First, there is this not very beautiful but technically interesting sampling scene here. Let me return to Cinema 4D, close this, what I did, and open the sampling scene. And what you see here is this setup. If I open up the IPR window, this renders immediately, and you see even a real-world scene updates very quickly. I have to set this as a render view such that the IPR picks up the changes. And I have different rendering effects in here. And this is to explain to you the sampling controls. So sampling is basically ray shooting. And ray tracer works by shooting a ray for every pixel into the scene, and the ray collides with the geometry and samples the color of the object it finds. And this is controlled by this section here under sampling. You have different sliders. The first is called camera, and this is the number of rays per pixel that Arnold shoots into the scene. So this is your global quality control. And to keep it simple, this is the most important slider of Arnold. If you really don't want to bother with the settings, what you can do is if you move this slider to the right, the rendering gets slower and better, and if you move it to the left, the rendering is fast and grainy. That's all to it. If you want, you can dive deeper and understand all the other controls, but really using Arnold is using this slider. Here at the moment you see in the shadow areas a lot of noise, and if I up the slider, this noise will eventually vanish. That's really it. But to speed up the process, Arnold differentiates between the different ray types. Whenever a ray hits an object, it sends out secondary rays together all the other effects like indirect lighting or diffuse, specular reflections, blurry reflections, and all stuff like that. And this is where all these sliders come into account. If I turn down all the sliders to 0, what I have is only direct light. That's because now Arnold shoots one camera ray per pixel, and this ray finds nothing but the direct light, so everything is black. Next is the diffuse slider. This controls the number of diffuse rays that are generated per eye ray. So if I go to 1 here, the diffuse lighting is appearing, because now every ray can send out secondary rays to sample the lighting. Same holds true for glossy. If I go up to 1, the glossy sphere starts to appear. And glossy is a solid angle term for specular reflections. So this would, in C4D terminology, this would be reflection. But in Arnold terminology, it's a little bit different. Glossy means reflection. Reflection means reflection too, but it's not that important. And then comes the refraction. I have a glass window here, which is black, but if I go up with a refraction rays, this glass appears, and the same holds true for subsurface scattering, which is ray traced too, so no need for computing point clouds or stuff, and for volumes, because Arnold is very good at rendering volumetric effects too. And then here at the bottom, you have the ray depth controls. Let me quickly explain what these are. If I go down with all of these, everything is black again, and that means, and that is because the rays are not allowed to bounce. These controls here define how many bounces every ray can do. So if I up the total amount of bounces and go up with diffuse to 1, now I see I have diffuse lighting. But I have no color bleeding because every ray can only bounce once and cannot see this turquoise surface, for example. If I go up to 2, the color bleeding is coming into the scene. And the same holds true for glossy reflections. If I go up to 1, I see the sphere, but the sphere is not reflecting in the reflective surface of the table, because for this to happen, I need 2 bounces. And the same is true for reflection and refraction. With refraction, I have a lot of glass windows here, and you have to remember that every ray has to travel twice through a window because a window has 2 surfaces. So to render all of these, I have to go up to 16 at least, and then everything is clear. So with these controls, you can really limit the bounces of the ray, and with the controls on the sampling, you can tell Arnold how many rays it should shoot, and this is your command central. So by defining the different ray types and by defining how many times the rays can bounce, you define the overall quality of Arnold, and that gives you the best trade-off between sampling time and quality. The only artifact that comes from a path tracer like Arnold is noise. So you won't see any flickering, even with animation, even with deforming geometry or changing point counts, because of the nature how Arnold is implemented. The only artifact, as I said, is noise, and what you have to do if you work with Arnold is you have to fight the noise. So you have to analyze your image, you have to take a look and understand where does the noise come from. The noise in the shadow might probably come from the light. The noise in the reflections comes from the glossy shader. So you have to understand where the noise comes from and up the ray type that creates the noise until there is no noise anymore, or until you can live with the noise. And that's what you do to render with Arnold. There is one exception, and that is at the motion blur and depth of field. Both effects are only anti-aliased, because they are distributed in time instead of space. And that means to get these noise-free, you have to up the anti-aliasing samples here. And be aware, these numbers here are squared. So if you put in 2, for example, Arnold actually shoots 4 rays. So if you go up with a slider, you create exponentially more rays, and the rendering gets quite slow, fast. Next up is the standard shader. The standard shader. I close this scene and open the next one. Again. Let me open the IPR window. Hello, what's going on? Yeah, I know what's going on. No, I don't know what's going on. This is the cool thing with live demonstrations. Now it's there. I don't know what's going on here. So basically, this is just a setup scene. What I have here is a material setup using images. If I open the shader network, you can see it's a quite simple shader. It's just this 2 nodes here. This is an image node loading an image, and this is a standard shader that is used mostly in Arnold. What Arnold works a little bit different. There is no such thing as a material as we are used to in Cinema 4D, but this material is only the container for different shaders. So you use different surface shaders to generate the look you want. What I can do is I can, for example, wire this image here directly to the output port of the material, and then I have my texture flat mapped on my surface. So what you do inside of this is really create or program a shader using different nodes. And this is a little bit tedious, but very powerful, because you can do whatever you like, and it's easy extendable via writing own shaders in C++. And there are a lot of third-party shaders, by the way, that can be installed in Arnold directly and work in Cinema 4D, because these are plugins for Arnold, not for Cinema 4D. But most of the time, if you do ArcViz or Cars or something, you don't want to build up a shader every single time, and that's why Arnold comes with a standard shader. And if I put in standard here, this is more or less, it's a shader, not a material, but it gives you the same controls as a Cinema 4D material. So if you want to start easy, what you do is connect the standard shader, and that's it. And in here, in the standard shader, you find all the well-known controls for the different rendering effects, starting with diffuse. At the moment, I have a diffuse surface, and you have this diffuse color here. If I change the color to red, you see the changes reflected immediately in the IPR, and under this color you have a weight slider. And you can understand this weight slider, of course, as a weighting factor, so a multiplication of the color, but it's used as in Photoshop with the layers. It's basically a layer transparency. So if you understand this diffuse effect as a layer, you can control the layer opacity with this slider. So if I go down to 0, I have no diffuse contribution. If I go up to 1, I have the diffuse contribution. The next thing I find there is specular, and as I told you earlier, this is reflection. And don't get confused, because the next tab is called reflection. This is a different implementation of calculating reflections that is in certain situations a little bit faster than creating the standard specular reflections, but you don't have to bother about this. You just use specular. Here's the same thing. If I go up with a specular weight, I get a specular reflection rendered. And then I have the specular color, where I can put in every color I like, and I can set the blurriness of this effect with the roughness slider here. The next thing is the reflection, and then comes the refraction, works the same. If I go down with my diffuse, I can up the refraction, and the object gets transparent. At the moment, it does not look like glass because I have no IOR set. It's set to 1. If I go up to 1.5, for example, I have a nice Christmassy looking glass sphere thing. And what I can do is I can use, on the specular tab, I can use a Fresnel effect. It's built in directly. And with this checkbox here, I can link this Fresnel to the IOR, such that I get a physically plausible material. Okay, let me dial this out again, and then we have directly on the standard shader, if I turn off all the effects, I have subsurface scattering, and it's really easy to use because I go up with subsurface scattering, and there is my subsurface scattering. At the moment it blows out white because the lights in the scene are a little bit strong, but let me go down a little bit, and you see this waxy look generated directly through ray tracing. Then you have this radius control. This is the penetration depth and tells the subsurface scattering shader how deep the light can penetrate the object. And there's a specialty with Arnold that you probably don't know from advanced render, and that is that this radius control is a vector. And that means that you can specify the penetration depths independently for R, G, and B. And this gives very nice effects. For example, if I let the penetration depths be 10 centimeters in R, but go down to 1 and 1 in the other components, I get this colorful absorption type effect, because now the different components of the light are allowed to travel differently deep into the object. And this is very powerful because, for example, if you shade a character, you want the blood that flows through the tissue gives a red effect in the light, and you want to show this, can be cheated very easily with this. And then, last but not least, there is an emission that's used to emit light. If I go up here, I have a white shaded object, and I see no light in the scene because the lights are so strong, but I can go very, very, very high with these values, and then the object is emitting a lot of light into the scene. So very straightforward, and then we have caustics and some advanced effects. So you can see this standard material is really very powerful, and I say 90% of the time you need nothing but the standard material. So you have best of both worlds. You have the power of the nodal workflow, but you have a very intuitive and easy to use standard material to use most of the time. So what you can do is you can build a preset, save it to the content browser, and then you have your standard material. What is nice too is that you have in the attribute manager, you not only have this button to open the nodal interface, but you can select every node of the nodal workplace here, for example, the standard shader, and then it exposes all the controls of the standard shader directly into the attribute manager. And that means you can really work with this new nodal network as if it were a standard material of Cinema 4D. Very easy to grasp. The next thing I want to show you is a car paint shader, because a car paint shader is something that is not built in right into the standard material, because metallic car paint has a specific property of 2 layers of specularity. So basically there's a base paint that has a roughness, and then there is a clear coat that has a very sharp reflection, and both are layered on top of each other. This is normally an effect that you just turn on if it is present in the rendering engine, but if it is not, you can create it layer-based, as it is done in physical at the moment. Close this one and open the next one. No, I don't want to merge, I want to open. You will see me clicking on this a lot. Here's a car paint shader I did. If I quickly open it, I am used to a bigger monitor, to be honest. It's a very easy setup. What you basically do is you have 2 standard shaders. And these 2 standard shaders are, I named them base layer and gloss layer. And the base layer has a setting for specular with a roughness of 0.5. And if I quickly wire just this into this port, and that's a very nice workflow too, because you can easily debug what you're doing, you see this is a base layer. And then I have this gloss layer with very specular reflections. Let me wire this to the port, and you see this is a gloss layer. And then I have just a mix node as an espresso, and I mix both of them with a factor of 0.5. You can choose every factor that you want. You have to have a look at your material in the real world, and if you mix both together, what you get is a layered effect. And it's very important to mix the two, because I see a lot of people adding the clear coat on top of the blurry reflection, but that's not correct, because it's very important to build energy conserving materials. So it's not correct if more light leaves the shader than enters the shader. And if you add the reflections on top of each other, this is what happens. That's why I use a mix node here. But it's perfectly possible to use an add node too. This is what I did down here. It's just another way of doing the same shader. You see, it's the same shader, but this time I used an add operation called plus, but what I did is I turned down the weight of the reflection to 0.5, so it's basically the same operation that takes place. So it's very easy to build these shaders, and because I have 2 shaders now that I have to control, I have to set the base color, for example, 2 times, but as I have a nodal network, that's not a problem, because I can use this shader here to just set the color and wire it to the both other nodes, and I get the color on both. So it's very flexible and easy to use. The next thing on my list is user data shader. The problem with third-party engines is the integration, because it's all nice and great if I can load geometry and put texture maps on it, but the render engine starts to shine when I am able to really get the data from my DCC to the render engine. And with MoGraph, for example, what happens is that MoGraph creates colors and stores it in the objects it creates in the display color field. And then in Cinema 4D there is a MoGraph color shader, and this shader reads this color from the objects and shades the objects due to this color. Very handy for doing effects like this. And Unfortunately, the MoGraph color shader is compiled for Cinema 4D and for advanced render, so it's not very easy for third-party engines to support it. And Arnold does not support it. But that's not important at all, because what Arnold supports is the data. And let me show you this. This is really unique, not found in any other third-party engine for Cinema 4D yet. And I'm excited about this because it opens up a lot of possibilities. Oh, no camera here, IPR window. So here's this effect. I have a cloner here, and the cloner is cloning these objects onto a grid, and then I have a shader effector with a standard setup. Under shading, you see I have a texture tag, and this is referring to advanced render material, and there I loaded the Aixsponza logo as an image. And what happens is, if I quickly close this window and convert the cloner with current state to object, what the cloner does is it writes the color to this display color field here. It's really nothing else that it's doing. And the problem is, if I want to use this color, I somehow have to fetch the data from the Cinema 4D environment and use it inside of the Arnold environment. And this is exactly what a user data shader allows me to do. So what I have here is, I have a user data shader. Here's a tab called user data, and here you find all the different data types you can bring into the Arnold shading networks directly from Cinema 4D. And this case here is a special case because it uses an inbuilt variable. You have to tell the user data shader which data to import, and in this case it's called display_color. This is how the standard Cinema 4D display color is encoded. And once I put it in here, Arnold reads the value, traces array, finds an object, understands which object this is, and reads the value that is set in the Cinema 4D container and uses this value in shading. And this opens up a lot of possibilities because, for example, if you use a lot of Python or Expresso, you can set all your shading colors on the user data of your objects and use them in just one shader. So create one shader for your entire scene and just put the colors into the user data there. And then what I do here is I feed this basic color through a gradient ramp where I put in a black body emission spectrum and a range node to remap the value range and put it in a standard shader again, and that's it. That makes these little boxes and spheres glow. And this not only works with MoGraph, but it works with every object. So if I, for example, let me quickly hide this. And it is gone if I create a cube and put exactly the same shader on the cube that I used on the MoGraph setup. The cube is silver, but if I go to the user data, no, not user data, but color settings, and I use on, I immediately get a color. And this is not the color I have here because it's going through this remap here. But if I wire the user data to the output directly, what you see is I get white. What I can do now, I can specify the color here, and Arnold picks it up and renders it. Isn't this great? It is. No, really, but it shows the deep integration of Arnold into Cinema 4D. It's really deeply integrated. You can use the data from Cinema 4D. You can write the data to us archives. Everything just works. And this is really, this was really a nice experience with this engine. The next thing I want to show you is a vertex map shader, because what I showed you at the moment was user data on an object level. So per object data. This is useful in a lot of cases, but what if you want to specify the color for different vertices? Unfortunately, in Cinema 4D, there is no concept like vertex color, known from other DCCs. But what we have is vertex maps, and vertex maps store a float value per point. And what Arnold did was using these vertex maps to create a shader. So basically, you can bring all Cinema 4D vertex maps into the Arnold shading context. And if you can do this, what you can do is you can specify 3 vertex maps, R, G, and B, and mix them together in the shader network and recreate your vertex color this way. So this is how I did this lava effect on this rock here. I did this in Houdini, by the way, with the curvature node and brought it in via the engine. Because the engine beautifully reads a vector attribute from Houdini and puts it into 3 vertex maps, and then I can use these vertex maps in Arnold. I could have used Arnold directly in Houdini too, but that's no fun. No, that is, by the way, very beautiful too, because Arnold really works in Houdini, Maya, Max, everywhere. And it's the same license. It's not really, as with other render engines where you have to buy an individual license for every DCC, but if you buy Arnold, you get Arnold. And you have Arnold in Houdini, in Softimage, in, I don't know, everywhere, and you can use it with one license. And it uses exactly the same structure. So if I export an S file from Cinema 4D, I can open it up and use it as a stand-in in Houdini and the other way around. So it really helps working together. It's a nice ecosystem. As it's made for studios, it has to be that way, of course. So vertex maps. Just quickly show you the vertex maps. Use camera. Fire up the IPR. My friend, the IPR. Needs a little bit of time to export the geometry, of course. Yeah. Undo view. I think this is a better problem. No, it's working. Here with this little box you can scale your output and you see direct rendering of this rock, and very fast. Once it's exported, it has everything in the cache, and it's very fast. Of course, it needs time to export. And what's going on here is I have this rock imported, and I have these vertex maps, and as you can see, the curvature information is written by Houdini into this vertex map here. And then I have this shader, this Arnold shader. If I open it up, you see it's a little bit more complex, but not that bad. And here I have this vertex map shader, and there is really nothing to set up this but dragging this vertex map into this port here. It works by name, so it uses this vertex map and puts out the vertex information as a black and white image, more or less, as a float variable, and then I can remap it again here to my lava gradient and mix it with the standard shader, and this way I get this nice effect of the rock being a second before exploding. So vertex maps are supported too. I hope support for vertex maps on splines will come. That's not working at the moment, but it's not released yet, so let's hope. Now to the next thing, skin shader. We have a pre-compiled, fully functioning skin shader. As I'm not a character guy, I used this freely available head of the founder of Infinite Realities, I assume. This is really a setup of 2 seconds. You put in 3 layers of scattering, you define the right texture maps, you have shallow scatter, deep scatter, mid scatter, and then 2 layers of specularity, and you get very realistic results in very, very short amount of time. You can, of course, extend the shader to your liking, but you don't have to. It is in there. Then I created this little architectural scene just to show you how quickly an HDRI setup is made. In Arnold there is an object called Arnold Sky, and it's really not very easy. You just put in a texture here into the sky object, and it renders as a HDRI and lights your scene. The only problem is if you first install it and want to import a texture, you don't find a texture slot, and that is due to the nature of Arnold. You have to open this color here, and then you find a drop-down called value type, and this is put to constant at the moment. That means I get a color field. But I can switch this to texture, and the color field vanishes, and I get a texture slot to put in a texture to control the variable with my texture. Another novelty for Cinema 4D users is particle rendering. And by particle rendering, I don't mean rendering instance geometry, because instancing geometry to particles and exporting this to the renderer is just not doable for things other than 4 birds or something. But something like this is not possible. And Arnold uses particle primitives. That means all the information you put to Arnold is just the point positions and nothing more. That's very lightweight. And then Arnold creates the spheres on render time. And not only the spheres, you can use Arnold stand-ins to instance on the particles, for example. And not only that, but as you can see in this image here, Arnold picks up the particle colors. Another novelty for Cinema 4D users, that you can actually render particle colors. I don't know what for I would use that, but I will find some use for it. Let me quickly open this scene. So it works beautifully with thinking particles, and it works with X particles too. Another specialty about the Arnold implementation is that they embrace the third-party plugins of Cinema 4D. So there is X particle support. A lot of you guys might use X particles, and there is Turbulence FD support directly built into Arnold. Very great too. Let me open the particle field. This is a quick setup. I imported an image and cloned particles onto the image and made the particles by Expresso pick up the color of the image. And then I set the size by different rules. So if I just generate the setup and press the IPR button, it renders particles. And it does so very, use as render view, it does so very quickly. This is 200,000 particles. Not that much, but it's enough, and it's quite as fast as the OpenGL view with rendering particles in Arnold. And you even can use motion blur on particles beautifully. You can even use vertex map tags to specify motion vectors for imported particles. So everything you ever dreamt of just works, and works fast, as you can see here. But it does not stop here. Cinema 4D does not understand volumes, but Arnold does understand volumes. And what you can do in Arnold, you can create beautiful volume renderings, as you can see here. As Cinema 4D does not support volumes, how do you tell Arnold which volume to render? Well, there is an open format called VDB, and this is embraced by the industry at the moment, so a lot of applications are capable of handling VDBs. And what I did is I created this donut in Houdini and exported it as a VDB. And Arnold comes with a procedural object that allows you to load VDBs directly into Cinema 4D. So now Cinema 4D has volume support through Arnold. Let me show you this. So basically what you do is you create an Arnold volume object and specify the path to the VDB here, and you get a bounding box in your scene. And let me fire up the IPR to show you what this gives. Instant rendering, because this time there is no need for exporting geometry, but Arnold can read directly the VDB, and this is very fast. This is why it renders so fast. So this is a simple setup from Houdini I exported. The cool thing is that it does not stop here. So to render volumes, it's not very complicated in Arnold. What you do is you create a shader called the volume collector, and you find the controls you would assume on a shader like this, the scattering, the attenuation, the emission. It's a lot like Krakatoa or rendering of TFD volumes, because this is a volumetric shader. And to bring in the density information, what you have to do is you have to specify this density grid here. So this is the information inside of the VDB that stores the density. It's called density. And it's very straightforward. What you have to do is you have to tell the shader that this density is what it has to render. That's why I put in density here. But it does not stop here, as I told you. Now, at the moment, it renders the donut I exported from Houdini. But what I can do is I have on the volume collector the sampling control here. And that specifies by a vector where in the VDB file the renderer is sampling. And what I can do, as this is a network, what I can do is I can just create a 3D noise, as in Cinema 4D, and connect it with this position port here. And what happens now is that the noise perturbs, I don't know, changes the location where the donut is sampled. And I get an instant cloud just by using the noise directly in Arnold. So Arnold samples the volume at different places now. It's not in the VDB. This is a render time effect. So between you and volumetric clouds, God has put Arnold. Buy it. and you will get volumetric clouds. The next thing is that you can render turbulence FD exactly the same, so no need for importing VDBs, but you can just create your turbulence FD cache inside of Cinema 4D and render it directly with a volume collector. Let me show you this TFD2. Oh no, I have no license for Turbulence FD on this computer because I need web activation. But fortunately, Jascha, the developer of Turbulence FD, is here and may quickly provide me with a license. Nein, eben nicht, das ist die Scheiße, ich kann es nicht zeigen, ich zeige das Bild, scheiß drauf. It's not that I cracked this, but I have no license because I'm not online. Unfortunately. But what you can see is this nice fractured cube, another digital asset from Houdini I brought in via the engine. Now, unfortunately, you have to believe me that you can render TFD. It's very straightforward. It's exactly the same process as with VDB, and it works beautifully. Just put in the name of the density grid. In the case of Turbulence FD, it's smoke. And then you not only can use the grids Turbulence FD creates, but you can use all the remapping controls you find inside of Turbulence FD. So you can really work as if you are working with advanced render, and it works beautifully, as you can see here. It renders fast, and it renders very, very nicely, and the big advantage is that you can render all your effects in one image. So no need for deep compositing anymore. Getting volumes right in compositing is always very tedious, and it's not necessary anymore because Arnold just renders it, as with everything, basically. Then another big thing is the procedurals. I created this birch forest here for you. So Arnold allows you to export whatever you have to an, they call it AS file, Arnold scene source. Not what you think. And the fun thing is, to render an AS file, you have to send it to kick, and then you kick AS. So basically, what it does is it's not render instances or something like this, but what it is, it really creates a complete Arnold scene using shaders and imported geometry and everything inside this AS file, and then you can use this to render it. And you can export these AS files directly from Cinema 4D, and you can load them in other applications too, as I told you. Here's one of these AS files. If I quickly open it, it's just plain text with a little bit of binary where the objects are encoded. And here you have, for example, the displacement entry. And you can even edit it by hand to use different passes or something. It's straightforward and works very nicely. And I have this birch forest here, and what I did is I have a cloner. Camera. I have a cloner, and this cloner has a render instances switch turned on. And that means Arnold really uses instances to render this. It's a special Arnold shape type instance, but these are geometry instances. All the shaders have to be instantiated again and stuff, and that's not that fast. But what I can do is I can go to Arnold procedural. I get a procedural object and then point it to the path of my exported S file. Where is my S file? Procedurals, S, open. And what I get is a bounding box. Let me turn off the cloner. And now I have this bounding box, and if I fire up the IPR, it reads in the S file. It has a lot of displacement, all render time displacement, and Arnold has to generate the dense geometry first. That's why it takes a moment to do its thing. There it is, including volumetric fog. Now I have this thing here, and what I can do now, I can create another cloner. Just duplicate this one and get rid of these two, and take my Arnold procedural, put it into the cloner. Now I have them distributed at the bottom, and I turn off align clone, and I turn off the random effector. And you see the IPR updating immediately, because Arnold has no need to export the geometry again or even apply shaders or do anything. The data is already inside the renderer, and it's, again, just a matter of giving point information to Arnold, which is very lightweight and fast, and you can render myriads of clones now. And another good thing is that this procedural is very lightweight for the graphic card too, that MoGraph suddenly gets fast. So I put 120 here, or I put 500 here, and it really does, it just does not matter. And Arnold is very, very good at scaling. So if it renders 2 of these birch trees, it renders 1 million of these birch trees. It's really, only RAM is the limit. That's a really nice workflow. And if you want to create something like this, you just select the object you want to turn into an S, click on this S export dialog, put in the path and which effects you want to export, and click on export, and that's all. That's all there is to it. It stores all the texture information and all the volume information, everything into the file, and you don't have to worry about it anymore. AOVs. Then there is another thing. Oh, I'm running out of time, I think. AOVs is another very, very great concept. In other applications, this is called multipath rendering or something. AOV stands for arbitrary output variables, and it's more than multipath rendering, because it's not that Arnold defined 5 or 6 utility passes for you, but it means that you can put every value you have in your shading network and put it out as an image plane. I prepared a scene to show you this. There is my rock. I love rocks, by the way. That's why all my scenes are rocky. And I fire up the IPR and give it a moment to export, because it's, again, quite heavy geometry. People are already leaving. Here it is. And this is the shading network for this effect. And here you can see. I need more space. I have different images loaded in. And here at the end, I have this AOV node. And this has a port that is called path through. Through there goes a shader, just to tell Arnold this is a shader to evaluate. And then you have an AOV input. And this is called, this AOV, I called my AOV. You can call it whatever you like. For example, butt, or something like this. And then you go to a nice little manager that's hidden here in the render settings, AOVs, set up AOVs, and you can add a myriad of predefined AOVs with useful effects like normal and indirect and all the different parts of the rendering process. But you can, with this button down here, you can add custom AOVs, as many as you like. You just have to name them, and then you have to remember this name. And you have to put this name here in this shader node, my AOV. And once you do so, what you get is, here in this menu, you get the AOV plane. So what I render at the moment is the pure input texture in black and white as an AOV. But you can really, whatever you have in your shader network can be rendered directly to an image plane. So that means for compositing purposes, it's very, very, very flexible, because you can have whatever you like in your AOVs and can set up all your compositing needs customly. You don't have to rely on whatever the software provides you, but you can very easily set this up. And to make it even more user-friendly, you get this object here in the scene once you use this AOV manager, and get an object for every AOV you have, and there you can specify the data type and the filter type for the channel. If you create your custom depth channel, for example, maybe you don't want it to be anti-aliased because you want to use it with Frischluft or something, then you can set this here. Very flexible and very great, and again reflects the paradigm of Arnold, that it really handles with or cares about data. It's all about bringing data from the DCC to Arnold and then handling the data. It's not that Solid Angle defined a predefined set of features for you, but it enables you to do what you have to do in your workflow to get the stuff done. Of course, there is native hair rendering directly in Arnold. So it not only supports third-party plugins, but it supports the Cinema 4D internal technologies too. hair rendering. This is a Cinema 4D hair object, standard hair object, with a Arnold hair material. And if I press play on this one, it renders quickly because the geometry is very lightweight. If I move the, first set it to render. If I move the camera, you see it renders very, very quickly. You have on the hair object, you have this Arnold tag here where you can specify the rendering mode for the hair. By the way, this works on splines too beautifully, so you can render your splines directly with Arnold. But it doesn't stop here. The Cinema 4D hair material is not only used to render it, as you probably know, but to shape it too. And Arnold reflects this. So additionally to this material, I have a Cinema 4D hair material. And I can go to this hair material and use, for example, the fizz. And Arnold reflects the fizz I put into the Cinema 4D hair system directly. And I can dial in the kink, for example. And the IPR shows me the kink. So very flexible, very fast, very high quality shading. It uses Kajia K, I think, and isotropic shading. And you can switch between the two in the hair shader. It's very, very nice system. Fast and reliable, gives you very good results. Okay, to conclude, Arnold supports motion blur. And by supports, I mean supports. So it blurs everything, even fluids. If you bring in motion vectors, you can even blur stuff that has a changing point count. And you can blur particles. And you can blur particles in a straight fashion, but as I heard on a presentation on Tuesday by Double Negative, at the moment the new big thing in Hollywood is curved motion blur on sparks. I thought I create curved motion blur on sparks, and if you have a close look, you see that the motion blur on the sparks is curved. Not only motion vector or straight blur, no, curved blur on particles inside of Cinema 4D. And this concludes my presentation, my quick walkthrough of Arnold for Cinema 4D. And now I have the pleasure to hand over the microphone to Marcos, the founder of Solid Angle, who will tell you a little bit about availability, pricing, licensing. Thank you very much.
Thank you.
Thank you.
Hello. Yeah, very quickly because we're out of time. But next week we're going to release the plugin. You'll be able to download it from our website, solidangle.com/Arnold/buy. So there will be a web shop where you can just buy the plugin. We are introducing cheaper licenses for freelancers or artists. We call those node lock licenses. They're 40% cheaper than our regular licenses. So you'll be able to use Arnold yourself for your personal artwork or even at studios. And I think that's about it. If you have any other questions, you can talk to us. Sorry to be out of time. Thank you.